Good morning, children. Today we are here to discuss Unit 9, what is inside atom of 9. Within this particular chapter, we are going to discuss one thing, that is what determination of atomic mass number of element with isotopes. With isotopes, we are going to identify the atomic mass number. What is called as atomic mass number? Total of protons as well as neutrons existing within an atomic weight of an element is called as atomic mass number. We are going to identify now, we are going to determine that one based upon one word that is called as isotopes. What are called as isotopes? Isotopes are the nuclei of an atom of same atomic number and different atomic mass number. Same atomic number will be there and different atomic mass number will be there. Already we have discussed clearly about the topic clearly there. Yesterday we have seen with examples. Now, how to identify the particular atomic mass number of an element by using isotopes? If you go for elements, we are having how many elements I said for you? 118 elements are there. These 118 elements cannot be existing in native stage. They will be existing in the form of mixtures of two or more isotopes. They can be obtained in the form of mixtures with two or more isotopes having same atomic number but different atomic mass number there itself. Two or more isotopes in the form of mixture, they can be existing. And each isotope has certain percentage, as it is having, if we take it is having a percentage of occurrence in native stage. Each isotope, if you see it up here, chlorine, I have taken one isotope called as chlorine. Another isotope called as chlorine, I have taken there itself. Whose atomic number is remaining same, mass number is varying. When it is existing in this particular way, the percentage of occurring in nature, occurrence in what? Nature of occurrence within the nature with certain percentage, with the native stage of chlorine it will have a percentage. If you go for chlorine of 17 and mass number is 35, if you take it up, this particular chlorine is having 75% of chlorine in nature, in native stage. But whereas another chlorine, if I am taking here, chlorine 17 of atomic mass is equal to 37. If I consider this one, here it will be having 25% of chlorine in its nature. If you compare this one is of 75% of chlorine in nature, if I compare this one is at 25% in nature, if you want to calculate atomic mass of chlorine atom, total chlorine atom, we have to consider in the form of average of these two atomic masses. If we do it up, we can get it up. How we can do the total average? I have taken chlorine, first one is, this is first chlorine, this is second chlorine. First chlorine I have taken here. And how much percentage is there here? 75% is there. If I am taking this percentage symbol by 100, I am doing it up. Plus 37, another isotope of chlorine I have taken 37. It is having how much percentage? 25%. If I take this percentage symbol, 25 by 100. Therefore cancel it up. 25 3 is 75, 4 is 100, 1 is 4 is. Therefore 35 into 3 by 4 plus 37 into 1 by 4, we got it up. Same LCM is there, add these two things. 35 3 is 104. by 4. 37 1 37 plus 4, that is equal to 104 plus 37 by 4, that is equal to 142 by 4, whose value if I calculate here, 142 divided by what? 4. 4 3s are 12, 2, 4 5s are 20, 2.45s are 20. Therefore, the value will be 35.5 is the actual atomic mass of chlorine. Actual atomic mass of chlorine, whose atomic number is 17, mass number is given as 35.5 of that particular concerned element. In this way, we can calculate atomic mass number of an element with isotope. With isotope, we can calculate. This is the determination of atomic mass number. Similarly, coming to applications or uses. Uses of isotopes, where we can use this particular isotopes. Isotopes are used in laboratory, especially first use is, it is used in laboratory to investigate the chemical reaction process, how the process is happening, to investigate the steps of reactions, how the chemical reaction is taking place step by step. Step by step can be easily identified by using an isotope there itself. First I use is that one. Second use, isotopes of uranium if I consider there itself. Uranium 92-235, uranium 92-237, 238 are isotopes. These isotopes, uranium 92, I said for you, uranium 92-238, uranium 92-235, if I consider these two isotopes. These isotopes are used as fuel rods. They can be used in the form of fuel rods in one reactor. That reactor is called as nuclear reactor. What reactor is called as? Nuclear reactor. Within nuclear reactor, uranium isotopes can be used in the form of fuel rods. That is second use of an isotope. Third use is what? Isotopes of iodine. If I go for isotopes of iodine, these isotopes are useful especially in what? For the treatment of thyroid. Nowadays so many people are suffering with thyroid there itself. So to reduce that particular thyroidness in our body, to make it to normal stage, we are using an isotopes of iodine. The medicine bottles we are treating it up, we are taking it up, consisting of isotopes of iodine percentage, due to which we can give a treatment for thyroid there itself. Next one is what? Isotope of cobalt. These isotopes of cobalt is useful for what? Treatment of cancer cells. So that nowadays, if any person is suffering from cancer, what they are doing there? They are doing therapy process there by incidenting isotope of cobalt rays on that particular cancer cell. So that what happened? That cell can be get destroyed. It can be get destroyed completely. So that what? For the cure of treatment of cancer, isotopes of cobalt can also be get useful. These all are nothing but what? Some applications or uses of isotopes we can give it up. Next one is what? Isobars. What are called as isobars? What more characteristics of an element of an atom? Isobars. Isobars are the nucleus of different elements, nuclei or atoms of different elements with different atomic number and same atomic mass number. Different atomic number will be there and same atomic mass number will be there. Example, if I take these all are examples only. Sulfur, whose atomic number is 16, mass number is 40. Chlorine, atomic number is 17, mass number is 40. Argon, atomic number is 18, mass number is 40. Potassium, atomic number is 19, atomic mass is 40. calcium atomic number is 20, atomic mass is equal to 40. If you check all these atomic masses, what happened there itself? They are remaining same. They are remaining same. Whose atomic mass is same? And atomic number is different, 16, 17, 18, 19, 20. Therefore, what this atomic number indicates that they all are of different elements, different natured elements. That is nothing but what isobars we can give it up. And one more example, that is what one more characteristic is what isotones for elements. There will be consisting of what isotones. What are these isotones? Isotones are nothing but what any two or more species of atoms having same number of neutrons. Within this atom, what happens there? And atoms will be having different atoms will have same number of neutrons within it. Examples, if I go for examples. Two examples I am taking up. One example I am taking it up. Chlorine, whose atomic number is 17 and mass number is 37. Potassium, whose atomic number is 19, mass number is 39. If I go for chlorine isotope here, see here 37, 17. If I am taking out 37 minus 17, I get how much? 37 minus 17 is equal to 20. I will get for 20 neutrons. Why means atomic number is nothing but what? Number of protons existing within an atom or number of electrons. Number of protons, or if it is 17, A minus Z is equal to A minus Z will give what? Number of neutrons. Therefore, 37 minus 17 is equal to 20 is neutrons required. Similarly, for potassium, if I am going it up, 39 minus 19, number of protons are 19, therefore 20 neutrons are existing. Therefore, same number of neutrons are existing between two different elements or different two isotopes of an element if you take it up. Between two different species of atoms having same number of neutrons, we'll call them as nothing but what? Isotones. Isotones. By this we have completed the total characteristics of atoms of an element, how it will be get existing. One is atomic mass, mass number, atomic number, atomic mass number. Next one is what? Isotopes. Third one is what? Fourth one is what? Isobars. Fifth one is what? Isotones. These are few characteristics. Does an element exist of an atom? By this we have completed our chapter. Thank you, children. Watch number of times to understand the concept. All the best. Thank you.